What's an algorithm? In computer science, an algorithm is a set of instructions for solving some problem, step by step. Typically, algorithms are executed by computers, but we humans have algorithms as well. For instance, how would you go about counting the number of people in a room? Well, if you're like me, you'd probably point at each person, one at a time, and count up from 0. 1, 2, 3, 4, and so forth. Well, that's an algorithm. In fact, let's try to express it a bit more formally in pseudocode, English-like syntax that resembles a programming language. Let n equal 0. For each person in room, set n equal to n plus 1. How to interpret this pseudocode? Well, line 1 declares, so to speak, a variable called n and initializes its value to 0. This just means that at the beginning of our algorithm, the thing with which we're counting has a value of 0. After all, before we start counting, we haven't counted anything yet. Calling this variable n is just a convention. I could have called it most anything. Now, line 2 demarks the start of a loop, a sequence of steps that will repeat some number of times. So in our example, the step we're taking is counting people in the room. Beneath line 2 is line 3, which describes exactly how we'll go about counting. The indentation implies that it's line 3 that will repeat. So what the pseudocode is saying is that after starting at 0, for each person in the room, we'll increase n by 1. Now, is this algorithm correct? Well, let's bang on it a bit. Does it work if there are 2 people in the room? Let's see. In line 1, we initialize n to 0. For each of these 2 people, we then increment n by 1. So on the first trip through the loop, we update n from 0 to 1. On the second trip through that same loop, we update n from 1 to 2. And so, by this algorithm's end, n is 2, which indeed matches the number of people in the room. So far, so good. How about a corner case, though? Suppose that there are 0 people in the room, besides me, who's doing the counting. In line 1, we again initialize n to 0. This time, though, line 3 doesn't execute at all, since there isn't a person in the room, and so n remains 0, which indeed matches the number of people in the room. Pretty simple, right? But counting people one at a time is pretty inefficient too, no? Surely we can do better. Why not count 2 people at a time? Instead of counting 1, 2, 3, 4, 5, 6, 7, 8, and so forth, why not count 2, 4, 6, 8, and so on? It even sounds faster, and it surely is. Let's express this optimization in pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. Pretty simple change, right? Rather than count people one at a time, we instead count them 2 at a time. This algorithm's just twice as fast as the last. But is it correct? Let's see. Does it work if there are 2 people in the room? In line 1, we initialize n to 0. For that one pair of people, we then increment n by 2. And so by this algorithm's end, n is 2, which indeed matches the number of people in the room. Suppose next that there are 0 people in the room. In line 1, we initialize n to 0. As before, line 3 doesn't execute at all since there aren't any pairs of people in the room, and so n remains 0, which indeed matches the number of people in the room. But what if there are 3 people in the room? How does this algorithm fare? Let's see. In line 1, we initialize n to 0. For a pair of those people, we then increment n by 2, but then what? There isn't another full pair of people in the room, so line 2 no longer applies. And so by this algorithm's end, n is still 2, which isn't correct. Indeed, this algorithm is said to be buggy because it has a mistake. Let's redress with some new pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. If one person remains unpaired, set n equal to n plus 1. To solve this particular problem, we've introduced in line 4 a condition, otherwise known as a branch, that only executes if there's one person we could not pair with another. And so now, whether there's 1 or 3 or any odd number of people in the room, this algorithm will now count them. Can we do even better? Well, we could count in 3s or 4s or even 5s and 10s, but beyond that, it's going to get a little bit difficult to point. At the end of the day, whether executed by computers or humans, algorithms are just a set of instructions with which to solve problems. These were just 3. What problem would you solve with an algorithm?
What is an algorithm? Algorithms are one of the most basic building blocks of computer software. Every piece of software you interact with, from your smartphone to your web browser to your coffee maker, uses an algorithm somewhere. So, what is an algorithm? An algorithm is a set of step by step instructions that is used to do something. With a definition that broad, it's not surprising that they are in everything. It might surprise you that you yourself probably use algorithms in your day to day life, even if you don't call it that. If you sort your laundry before washing, first let me say good for you. Second, you probably do it following an algorithm. Take a piece of clothing. If it's white, put it in the left pile. If it's colored, put it in the right pile. Repeat until you're done. That's an algorithm. The power of algorithms comes from the fact that computers can follow these steps quickly and very precisely. For example, how do you look up a name in the phone book? If you're like me, you plop the book open somewhere. If you've gone too far, open a spot closer to the front. Otherwise, move toward the back. When I feel like I'm close, I start going page by page, looking at the first or last name to know if I've gone too far. Computers can do better. A phone book is essentially just a sorted list of names. If you have 1,000 pages in the phone book, you can use an algorithm called binary search to require at most 10 page turns. It works like this. Say that you're looking for Jill Jackson. Start in the middle at page 500. The first name on this page is McDonald, so we've gone too far. We know the M in McDonald has to be after the J in Jackson, so the right page is before page 500. Divide the pages in two again and turn to page 250. This time the first name on the page is Flores. Now we've gone too far to the front. There are 250 pages left, so we divide by 2 and turn to page 375. We repeat this process until we find Jill Jackson, which will be at most 10 turns. This might be difficult for you or me, doing math on the fly and turning directly to the right page, but a computer has no problems with this. And an algorithm like this is efficient in terms of the computer's processor, meaning it scales amazingly well. This process takes 10 steps in a 1,000 page phone book. If we switch to a phone book with 100 million pages, it would still only take 27 steps. Algorithms can also do more complicated things. PageRank, the algorithm underlying Google search results, is one example. There are lots of pages on the internet that talk about cheese. If you search for the word cheese, which results would you expect to get and how would they be ordered? A naive approach might be to rank most highly the page with the most occurrences of the word cheese. Unfortunately, that breaks down pretty quickly when you think about a very long page with just the word cheese repeated over and over. While it might have the most occurrences of the word cheese, it probably isn't the page you want. So, how does Google do it? In the early days, at least, they used an algorithm called PageRank. They start the algorithm by crawling every page on the internet and keeping track of what other websites link back to that page. The logic goes that an important page will have many more links pointing at it from other pages than an unimportant page will. Each link is also scored, with links from other important pages being worth more than lesser links. The logic behind that decision is that if your page is linked to by whitehouse.gov, Wikipedia, and the New York Times, those three should be worth more than links from your 10 best friends websites. At the beginning of the algorithm, each page is given a starting value of 0.25. As new pages and links are explored, the score for each page is updated. A link to a page confers that page's own value divided by the number of links on the page. In other words, if a page has a value of 0.25 and only has one link, that link will add 0.25 to the page it links to. If it has 5 links, each of those links is worth 0.05, 1/5 of the original value. After crawling the entire web, each page ends up with a score ranking its importance. When you search for a phrase, you are given a set of results based on the content of each page, does it match your query, as well as the page's importance, does Google give it a high PageRank value. Google's system has evolved and become more sophisticated, but PageRank remains a defining algorithm of the web. Algorithms underlie all the code running everyday things like the internet to the most sophisticated machine learning projects in the world. Underneath the covers, they are really just following a set of instructions, an algorithm.
Work wish is a blessing, don't mess it up all again. Money, it come and it go and it come and it go again. Loving is true, it don't go here to stay, it go again. Bumping into trouble at a rubbles where I came. See the flame shine bright, they were puzzled how I'm saved. I could never serve the passion or the fire or the man or for sight how I am. Ain't nobody asking, I've been basking in my liberty, cause slavery is real. Doesn't mean the shackles gotta be revealed. Fighting with my pen, that's the closest thing to steal, and they sweat.
So this is a quick tutorial making sure that you understand exactly what pseudocode is. I've had 2 questions in this via email, and I want to make sure that before going on to the other tutorials or working with the other exercises, everyone understands what pseudocode is. Pseudocode is just an English-like way to state an algorithm. It's like communicating with somebody regarding the instructions which will solve a problem. I have 2 problems here written on the screen that I'll go through, make sure you understand the problem, and then I'll write the simple pseudocode for it. It's important to know pseudocode is not syntax, although typo there, right? In your I for number 1. And once I do that, I have to make sure that I save whatever they entered into a variable. And in my pseudocode, I like to go ahead and reference the variable names. Then I know I need to next prompt the user. Then I should have a null while I'm typing this at them. Now, is this the exact and only rhythm she could have come up for this problem? So, just an English-like way to solve the problem. So, contact solution. We're so compute action. So the first thing we need to do is acquire the number. You put check mod, and then we print or calculate it was, and we're equal to samples. Now or email me.
What are data structures? The reason we are talking about this is because if you look at the internet, everyone says if you want to get into this company or that company, they will ask you a question based on data structures and algorithms. So first of all, why such a hype and what exactly data structures are? So before we get into data structures, let's talk about data. See, the entire software industry is based on data. When you do a course on IT, which we call information technology, it's not about technology, it's about information because we work with information. So data is everything. So it doesn't matter what technology you learn, you basically learn or you work on it so that you can work with data. Example, think about programming languages. Why do we use programming languages? To process the data. Why do we use database? To store the data. Why do we use AI? To generate data or to understand data, right? I mean, just to bring it down, everything is data. Now then question arises, what is data structures? Now if we talk about any programming language, we have something called primitive data types. If you want to store a number, we store that in integer. If you want to store a text, you store that in a string. If you want to store a character, you store that in a character. Of course, depending upon different languages, the term or the way you store it changes, but ultimately you have some types to it where you store the data. But what if you have bunch of data and if you want to store them? It's not just about storing data. Anyone can do that. It's about how do you store data efficiently, and you can also save some memory. The thing is, if you simply dump the data, you are expanding the memory, and if you want to search something from the data, will be difficult. And that's why storing that data efficiently is very important, and that's where data structures comes into picture. So data structure is a way to organize and store data efficiently. Okay, so when you say efficiently, it means 2 things. First, in terms of performance, and also in terms of the memory. Now, what about performance? Now think about this. If you talk about any software application which we use, it can be a normal calculator, or it can be an application like Amazon website, or any application which we use, a banking application as well. Now, what we do in that application is we use some features using which you can compute something, you can process something. Example, on calculator, you calculate. On the banking website, you transfer money. So what you're doing is you are basically building an application which will do some processing. And the way you build an application is through algorithms. Now, what are algorithms? Set of instructions. Let's say if I want to add two numbers, it's very simple. What you do is you say, take two values from the user, then perform the operation and give the value back to the user. Now, those are the steps, right? Those are instructions. Now, what I have mentioned, the instructions, those are called pseudocode, because we're not actually typing a code here. We're not being specific to a language, let's say C, C++, Java, Python, JavaScript. What we are simply saying is, these are the steps you have to follow, and that's your algorithm, right? But yes, when you want to make it work, you have to convert that into a code which will run on the computer, right? That's your actual software code. And you can use any language, doesn't matter, right? But the pseudocode will remain same. Now, when it comes to processing of data for any task, it's important for us to make it fast and also save memory. Now, most of the companies are focusing on this concept of data structures is because they want to give a good experience to the user. Of course, right? If I'm using some application, I want it to be fast. Now you will say, okay, to make the system faster, you can increase the CPU speed, you can increase the amount of RAM. You can do that. But what if with the same amount of memory, same amount of CPU power, you can still make it more faster, right? And that can be done with the help of data structures. Now, if you know how do you store that data efficiently in a proper structure, and by doing that, you can make your application faster. Because in data structures, we have different type of data structures. Example, let's say if you have a bunch of data, you can store that in an array. But apart from array, we have other types as well. We have set, we have linked list. So when to use what? It's not that this is best or that is best. It's all about when to use what. And to understand when to use what, you have to first understand what those things are, right? How do you decide that this time you have to use array, this time you have to use set? And that's where understanding these concepts are very important. Now, these are not the only options we have. We have tree, we have graph, when to use them. So when you understand those concepts, then we can think about, okay, for this situation, we will use this. And this is why companies are preferring candidates who knows DSA. It will help them in multiple ways. First, it helps them to reduce the cost is because every computation, see, I know you might be thinking, most of the applications which we use are free, right? Think about Instagram. Now, when we use Instagram, of course, we are not paying for it, but then companies are paying for it, right? So the Meta is paying for you to use Instagram. So because those computations will be happening somewhere. Maybe Meta is using some cloud service. Let's say Amazon is in this case. So Meta is basically paying to Amazon for every computation which you do. Okay? Of course, they earn from ads, but then they are paying for it. So what they will do is they will try to optimize it. They will say, okay, if one query takes, let's say, $1 or maybe half a dollar, can we just reduce it more? Can we just make it 10 cents? So that's the thing they are trying to do. And the way you can do that is by making sure you use a proper algorithm with a proper data structure. So why companies are doing it? To reduce the cost. Second, to give as well, so as a customer. Next, now data structures algorithm becomes one of the way to filter the candidates. Because if you know data structures, that means you have worked a lot on that particular language and you understand how a particular system works. On the other hand, data structures are not the only thing you need to know. If you want to be a good developer, if you want to get hired, there are multiple things needed. Example, you need to have a good hold on a particular language, a particular technology. You should have worked on few projects, understanding the entire ecosystem, not just one language. Working with databases, working with networking, but then DSA becomes one of the important things there. So just to summarize, what are data structures? So data structures is basically a way to organize and store your data in the efficient way. And there are multiple data structures option available there. And you will understand that in the upcoming sessions we're going to talk about. In the upcoming videos, we will talk about what are the types of data structures we have, how to use them, when to use what, and what are the algorithms available there. So I hope you got some
Boost your mobile games revenue with rewarded
Structures is basically a way to organize and store your data in the efficient way, and there are multiple data structures option available there, and you will understand that in the upcoming sessions we're going to talk about. In the upcoming videos we will talk about what are the types of data structures we have, how to use them, when to use what, and what are the algorithms available there. So I hope you got some idea regarding data structures. So of course entire series is important to understand that properly. Welcome back, aliens. My name is to Amazon for every computation which you do. Okay, of course they earn from ads, but then they are paying for it. So what they will, $1 or maybe, so you use it to use it. I search something, it should be people. They have so many candidates, right? How will they filter? Because if you and how a particular system works. On the other hand, data